Welcome to another limit video. This is in fact my example number 9, and today I'm going to investigate limits that involve absolute values. Now, absolute values are very unique functions, and they have an interesting way for us to approach their evaluation. But before we get crazy with the mathematics, the first thing you should always do when you obtain a limit example is to look at the value that x goes to. In this example, x goes to 2, and substitute that into our expression to see what type of answer we obtain. So we'll do some algebra, a wee bit of house cleaning, and we obtain the answer 0 over 0. Now this is an indeterminate form, which is just a polite way of saying that we will be using algebra to assist us in evaluating this limit. Now recall, there are other indeterminate forms besides 0 over 0 that you should look out for, and that is 0 times infinity, infinity divided by infinity, infinity minus infinity, 0 to the 0, infinity to the 0, and even 1 to the infinity. So let's go and have a look at our expression. Now, this is an absolute value function that we're going to be looking at the limit with. Now, when you get absolute values, one of the algebraic techniques that you're going to be using is something called piecewise functions. Now, a piecewise function is just an interesting way of having an expression that has multiple rules that you can use. So in this example, we have an absolute value, and our piecewise function has 2 rules. These are the rules, and the rules basically say, the top one says whatever comes into the machine, just multiply it by -1, while the bottom rule says, hey, whatever comes into the machine, just leave it alone. Now the question is, with piecewise functions, is how do I know which rule to use? And that is what usually follows the semicolon. And these are like if-then statements. So the if-then statement would say something like this. It says x is less than 0. So if x is less than 0, so if a number that comes into the machine is less than 0, apply the top rule. And the bottom if-then statement says if x is greater than or equal to 0. So if x is positive and it comes into the machine, then just leave it alone. So let's look at that in a bit more detail. So here's my piecewise definition of my absolute value without any numbers substituted in. We will plug in a value here. So let's substitute in a -4. So the first thing we look at is the if-then statement. And the if-then statement gives us 2 choices. It says, hey, if whatever comes in is less than 0, apply the top rule. And if whatever comes in is greater than or equal to 0, apply the bottom rule. Well, what came in is -4. And -4 is less than 0. So we are going to apply the top rule. And the top rule says, hey, whatever comes in, make it a negative of whatever it came in. So the negative of -4 is in fact +4. So the absolute value of -4 is in fact 4. So this is the technique that we want to apply to our limit question above. So let's look at that. Now, it's always a good idea, because we know we had an indeterminate 0 over 0. So look at the value that x goes to, treat that arrow sign like an equal sign, bring the 2 over to the other side, and we obtain x minus 2. So therefore, x minus 2 will go to 0. And we're trying to cancel out, delete those 0 over 0s, so we should look for an x minus 2 on the numerator and x minus 2 in the denominator that we can cancel out, and thus cancel out our indeterminate forms. So with that piece of advice in mind, let's go to our function. And we're sitting there saying, okay, we got to somehow apply our piecewise definition. So we won't panic. We have to figure out where is our trigger point for that if-then statement? Remember, in our normal absolute value, the trigger point was 0. If x was less than 0 or x is greater than or equal to 0. But where do we get that 0 from? How do we know what our trigger point is? Look at the term that has the absolute value. That is absolute value of x minus 2. Well, set that equal to 0. And if you set that equal to 0, you can now actually solve for x. So absolute value of x minus 0 is equal to x minus 2 equals 0. X equals 2. So that's the trigger point. So if x is greater than 2, then I can leave my material alone. The absolute value does absolute nothing. But if x is less than 2, then I've got to make my material somehow positive. So we'll take these guys, we'll set them up over here. So we'll look at the situation where x is greater than or equal to 2. Well, if x is greater than or equal to 2, the absolute value does absolutely nothing. So what you should do is just turn them into round brackets. So we'll turn them into round brackets. Now, because x is greater than or equal to 2, you notice how I have x going to 2 from the positive side. It's just reminding me that x is greater than or equal to 2. I've taken my absolute value brackets, I've just turned them into round brackets. And we're done with that bottom part, or the bottom rule of my piecewise function. The other if-then statement says, well, what happens if x is less than 2? Well, if x is less than 2, the material inside the absolute value has to be turned into a positive. And the nice, easy way to turn material that is negative into a positive is to multiply it by -1. So I'll take my absolute value, turn them into round brackets, and just stick a minus sign. That is reminding myself I'm multiplying the stuff in the brackets by -1. Notice how I'm also reminding myself that x goes to 2 now from the negative side because x is less than 2. Now, simple algebra, I'm actually doing algebra to two components simultaneously. You notice how I have an x minus 2 in the numerator and x minus 2 in the denominator on the top rule, and I also have an x minus 2 and an x minus 2 on the, in my bottom rule, so I can cancel out all those beasties. And if I do that division, my limit definition simplifies to -1 on the top when x is less than 2, and 1 on the bottom rule where x is greater than and equal to 2. Well, hang on a second. We're trying to figure out the limit as x goes to 2, and it's telling me that I have two possible answers. Well, my limit can only exist if I have one answer, not two answers. So in this example, our limit does not exist. We have two possible answers. Hopefully this was helpful. Thank you.